All right, here we go. We got a lot of stuff to cover. We've talked about shifts and we've talked about reflections. We haven't talked about vertical stretch or shrink. And we haven't talked about horizontal stretch or shrink. So we're going to lay that out for you today. Whoop. Great movie with the knee. There we go. Compression, shrink means the same thing. So we have y equals x squared, we have y equals 2x squared, and we have y equals 1/2 x squared. And over here, I'm going to put y equals x squared, y equals quantity 1/2 x, no, 2x squared, quantity 2x squared, and then y equals quantity 1/2 x squared. Boom. Okay. The 2 and the 1/2, are they on the outside or inside? Outside. If it's on the outside, it affects the graph in a vertical manner. The 2 and the 1/2, outside or inside? If it's on the inside, it affects it in a horizontal manner. Does that make sense? That's the number one thing you need to learn from this unit. It's on the inside, horizontal. It's on the outside, vertical. Now, if you see a 2 in front like that, it's simply a vertical stretch by a factor of 2. What do you think will happen if we have a 1/2 in front? Vertical shrink. Now, here's what you have to understand. If I have a parabola, and I'm going to take that, and I'm going to shrink it vertically, what happens to it horizontally? It expands, right? It stretches. And if you take a parabola and you stretch it vertically, what's going to happen horizontally? It's going to draw together. It's going to compress. It's going to shrink. Okay? So look at this. Here you got y equals 2x squared. When you square that out, you would get y equals 4x squared, wouldn't you? That's going to stretch it vertically. What's going to happen to it horizontally? Shrink. So when you see the 2 on the inside, it's not a stretch by a factor of 2. It's a shrink, horizontal shrink by a factor of 1/2. It's going to be 1/2 the size. And if you have a 1/2, you might be like, oh, it's going to horizontally shrink. No, Think about it. This is 1/4 x squared. So it will be compressed or shrunk vertically, which will stretch it horizontally. So horizontal stretch by 2. So you notice it's the reciprocal. So when you look at that number, you take the reciprocal, and that's what happens. If it ends up being greater than 1, it's a stretch. If it's less than 1, then it's going to be a shrink. Got it? Okay, let's put all these together. If you have the function y equals f of x, and you decide to put some transformations on it, for example, let's suppose you stick an a out front. We're now going to summarize how these different pieces affect the graph. If you put an a in front, is that on the outside or inside? So is it going to affect it vertically or horizontally? It does a vertical stretch or shrink. Vertical stretch or shrink. That's what happens. Now, also, something happens if a is positive and if a is negative. If a is positive, it goes which direction? up. If A is negative, it goes down. It'll be reflected over the x-axis. We talked about these vertical reflections the other day, correct? All right. Now, let's look at this B value right there. Is that on the outside or inside? Inside. So is that horizontal or vertical? Horizontal. Stretch. Or shrink by factor of 1 over B. It's the reciprocal that happens. And remember, what happens if you have a negative value in front of the x on the inside? Reflects over the y-axis. So I kind of think about it like this. If B is positive, it's normal. It would just be going, you know what, you would graph it going to the right. But if it's negative, then you got to reflect it over the x-axis or y-axis. That's the way I think about it. I should write reflect over y-axis, but I'm lazy. I've been up since 3 today. I woke up at 3. I could go back to sleep. Yeah. Look. Oh my gosh. Oh. No apples involved. No, 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 no. I don't feel bad because even on my worst days, I look better than Will on his best days. All right. Schaefer, what'd you say? You want to call me out? Oh, wow, you're blaming everybody. Whoa, Halloween came a day early. All right, here's what we're going to do. Okay, it's on. All right, so we got bx minus c. When you see this minus c, is that on the inside or outside? It's on the inside, so it affects it horizontally. This is a horizontal shift. It's a horizontal shift that's going on here. And what we do is we take whatever's on the inside and we set it equal to 0. So bx minus c equals 0. Solve for x. And that will tell you exactly what the shift is. If it's positive, it's to the right. Negative, it's to the left. And we got the easy one. Is this d on the outside or inside? So is it vertical or horizontal? Vertical. Shift. To units. If it's plus 3, it's up 3. If it's minus 4, it's down 4. That's all there is to it. So what we want to do is we want to take these type of problems and apply them. We're not going to give you a rule. We're not going to give you x squared. We're not going to give you square root of x minus 3. We're going to give you this. So we want to take this function, which doesn't have any rule. It just simply has these segments, and it's attached at these points. So copy down these points for a table. And we are going to perform transformations on that so you can understand in a more abstract sense what's going on. While you guys are doing that, I'm going to put that shape down here. The smaller graph, it's nice if I put one down here as well. -4, -3. So nice you guys got these videos now. That way, like if it's, Christmas break, you haven't heard my voice for a while, you just turn on YouTube at night and border. Everybody would like it. All right. All right, here we go. So that is our shape. Here's what we want to do to it. The 2, is that on the inside or outside? It's on the outside. So does that affect it vertically or horizontally? vertically. So if it affects it vertically, is that going to change the y values or the x values? The y values. So as you see this, y equals 2f of x, that's going to stretch it vertically by a factor of 2, correct? It does nothing to the x values. So the x values stay -4, -2, 0, 4. Those are the values that we had, correct? But the y values, what do you think we do to those? We multiply by a factor of 2. So let's do that. Take your y values, and we're going to have -4, +4, -4, and -4. I multiplied my y values here by 2. Right here. So as you plot this, -4, -4, -2, +4, 0, -4, and 4, -4. Does this look like this? Is this a similar graph? Yeah, it's just been stretched vertically by a factor of 2. And you can see that. So when you graph it, it should say, yes, what I thought was going to happen did in fact happen. Look at your next one. Order of operations here. If you plug in a value for x, do you multiply it by 0.5 first, or do you add 1 first? So we've got to take care of that 0.5. Is 0.5 on the inside or outside? Inside. So horizontal or vertical? Horizontal. So is that the x values or y values? X. So we're going to change the x values. Now, think about it. 0.5 on the inside. What does that do horizontally? Stretch or compress? Stretch by a factor of 2. The reciprocal of 0.5 is 2. So this is a stretch by a factor of 2. So we got to take all the x values and multiply them by 2. So we get -8, -4, 0, and 8. Now let's do with the +1 on the outside. That +1, does that affect the x values or y values? The y values, because it's on the outside. So I'm going to take all those y values that we have up there, and I'm going to simply add 1 to them, because it shifts it up 1. So that becomes -1, +3, -1, -1. When I graph this, so proud of you guys. First time I've ever taught this lesson. None of the 3 classes have complained that these end up off the grid. And now you start groaning. Okay, yeah, no big deal. Just draw it. Does it look like it's been horizontally stretched? Yes, it does. Does it look like it's shifted up 1 unit from what the red was? Yes, we've done it correctly. The next one. What do you deal with first in this problem? The negative, the -1, or the -3? The -1. It does matter, okay? We deal with it in the right order. And you decide by order of operations. If you were to plug something in for x, what would you do first? First thing we do would be subtract 1. What does that -1 mean on the inside? If you see on the inside a -1, what does that mean? Move to the right 1 unit, because you plug in 1 to solve for 0. So that means 1 unit to the right. So we're going to take the x values and add 1 to all of them. So -3, -1, 1, 5. What do I deal with next? The negative or the -3? The negative. Okay, negative on the outside. What does a negative on the outside do? Flips it over the x-axis. So think about this. If your value was +5, it will now become -5. If your value was -3, it would become +3. So you just switch the value of the outputs. And after I switch the value of the outputs, then I will shift it down 3 units. So watch what happens. This first value here has an output of -2. It will flip to become +2 and then shift down 3 to -1. So we just take these values. We take like positive 2. You flip it over, it becomes negative 2. Subtract 3, negative 5. These other ones, flip it over, positive 2, subtract 3, negative 1, and negative 1. Then we graph it to see if it looks like, we thought it should. As you compare it to the red graph, is it the same size, or is it bigger, or is it smaller? Same size. I have not horizontally stretched it or compressed it. I've not vertically stretched or compressed it. That's the same size. The only difference, I've flipped it vertically, which is a negative, and I've shifted it 1 unit to the right and 3 units down. Last one. Oh, that was bad. X and Y. What do I do with first? The 2, the negative, or the plus 2? The negative. What does the negative on the inside do? Flips it over the y-axis. When you flip something over the y-axis, does that change the y values? No. Does it change the x values? Yes. So you switch the x values. So we end up with positive 4, positive 2, 0, and negative 4. What do I deal with next? The 2 times or the plus 2? 2 times. Does that affect the x values or the y values? Y values, because it's on the outside. So you will multiply the y values by 2, and then you will do a vertical shift, so add to the y values. So let's check our y values. We've got negative 2. What's negative 2 times 2? Plus 2? Negative 2. What is 2 times 2? Plus 2? 6. And we get negative 2 and negative 2 again. So 4, negative 2. 2, 6. Oh boy. There we go. 0, negative 2, and negative 4, negative 2. Does that look like it's reflected over the y-axis? Yep. And is it stretched? Yeah, it's definitely bigger. So, excellent. You're going to have to do that kind of a problem on the test, I promise. Which means you need to practice today. So I got an option. You can choose one of 2 assignments. You can do 1 through 12 or 1 through 76. Whichever one you want. Well, you can't just do 1 through 53 either. You need to do 1 through 76 if you're going to do it. So I believe in giving students choice, so there's your choice. I thought you would laugh. Schaefer's laughing. Yeah. Yeah, if you want to do 1 through 76 instead of 1 through 12, you can. That's fine. Oh, yeah. Yeah, you do. No, you have to do 11 and 12. So you can do 11 through 76. Or 11 through 76. There you go. Haley's going to do them all. She wants to do them. She's ready. Who are we missing today? Anybody? Ashley. Ashley, we miss you. We hope you're doing well. Do some math.